Let's continue with question 11. A long straight wire carries 6 amps current is directed in the positive x direction. Now, a uniform magnetic field is applied perpendicular to a 3-meter segment of the wire. The magnetic force on the segment is 0.36 newtons, is directed in the negative y direction as shown. Actually, it's not really shown here, but we're going to draw this together. And what are the magnitude and direction of the magnetic field? So I'm going to start off by rereading the question one more time to jot down the information. And what we have here is 6 amps current, so and it is going in the positive x direction. Now next we have a uniform magnetic field is perpendicular to a wire of 3 meters. That means that we have a wire of 3 meters and the magnetic field is going to be perpendicular to it. So and that means that the angle between B and L, so the angle between these two is going to be 90. And we will need to find the magnetic field. We need to know the value of it, and we also need to know the direction. As you can see, all the options in here show value and the direction. Now, it is true that this is a multiple choice question. I really like these type of multiple choice questions because they are simple word problems, like where you have to calculate and it just are given different options for the answer. So you kind of have an idea what the answer can be, and you just have to select the right one. And when you're writing a test, it is very important to just show some work, just in case you select by mistake the wrong option. You won't lose the full mark in there because you will show that you do have an understanding, and just a minor error can lead to the wrong answer in here. So we're going to start off by drawing the 3D space, and we have here the x-axis. This is the positive and this is the negative x-axis, the positive y and the negative y, the positive z and the negative z. Now in some books you will see that z is positioned here perpendicular and here is y. It doesn't really matter, so as long as we are actually placing them perpendicular to each other and we indicate the directions. So now recall that every good problem starts with a good diagram, and we're going to get started with our formula. We need to find B, and B is actually connected with I and L and angle theta in the magnetic force formula. So we have the formula, and we are going to start off by drawing the diagram. So I is going to the positive x, and then we have the force F that is heading in the negative y, and we need to find out the value of B. So we're going to discuss this together a little bit later, but or you can right now try to look at the FBI rule. So place your finger, the pointer, along I, and position your 3 fingers, so the FBI, position them so that the force will point down, and you will see that the magnetic field line will be coming out of the page. So we know the direction of it, so it's coming out of the page. It's going to be perpendicular to both FM and I, which means that the magnetic field line is going to be coming out of the page in this direction, like this way. Now, let's get to work and perform the calculations. So we are trying to isolate B, and for this, we're going to write B equals F divided by IL sine of 90, because angle theta is 90. Sine of 90 equals 1. So we will substitute everything. So we have F over I times L, and then substitute the values of it. 0.36 for F, 6.0 for the value of the current, and 3 meters for the value of the length, and we get B equals 0.020 Tesla. So that means that the correct option here would be option A, so 0.02 Tesla. And I hope this made sense. Thank you for learning with me. Bye for now.